Hello, everybody. Hello. This is heteroskdasticity, and these are the major issues to be covered in the section. And the basic concepts of heteroskdasticity will be discussed, and we will consequences for OLS estimators when heteroskdasticity, how this will affect OLS estimators, and also testing for heteroskdasticity. And we will see how we can correct heteroskdasticity using weighted least squares. We can correct heteroskdasticity or generalized least squares. And also we can go for feasible generalized least squares. And finally, we will have starter application. And the heteroskdasticity is the first part of chapter 3. First part of chapter 3. So when we define heteroskdasticity, it is the assumption of heteroskdasticity is relaxed when there is heteroskdasticity. What is the assumption of heteroskdasticity? That is, the variance of error term is constant for all observations. We are going to relax that assumption when there is heteroskdasticity. Heteroskdasticity occurs when the variance of an observed error, the error is not observed. And that error, the variance of that error is not constant for all observations. And the symbolical or mathematical expression of heteroskdasticity is this. The variance of the error depends on X variable. So for sigma squared subscript I mean that for each observation we don't have constant variance. Constant variance means if the variance is 2, it is 2 for all observation. But if it's not constant, sigma squared I mean that it is 1 for observation 1, 0.2 for observation 2, and it is changing for each of the observations. We have different variance. That is just the case. That is the case of heteroskdasticity. Here, heteroskdasticity associated with one of the explanatory variables, that is X. Variance of the error term depends on X. So in particular, the variance of the error may be function of independent variable X. So alternatively, we can write like this. So the variance is just what? Just constant variance times the function h of x. Here, the variance varies as x changes. That is just the case we will have. That's the case we will have. So that is the definition of the variance. So here I have good example for you. That is estimating saving on income, and we assume the variance differ by income level. Okay, the variance differ by income level. We are dealing with the saving. Saving is function of income, and that means that saving of rich households is more variable than saving of low-income households. So the variance of the saving differ between low-income people, middle-income people, and high-income people. That is just the case we'll have. That is the case we'll have. So the variance differs across each individuals we have. So that is the case So okay, let me adjust the video and so the variance is this, and we can have. So the variance varies, the saving is more variable among rich households than middle income and the low income householders. Okay, I will pause the video and then